How do nanofluids enhance thermal conduction? Imagine tiny particles so small they are measured in nanometers, much thinner than a human hair. When these particles are mixed into liquids, they create a special kind of fluid called nanofluids. These nanofluids are used to transfer heat more efficiently, but how exactly do they do that? Let's explore the science behind this fascinating process. Nanofluids improve heat transfer mainly because they contain nanoparticles suspended in a base fluid like water, oil, or glycol. These nanoparticles, often made of metals or carbon-based materials, have much higher thermal conductivity than the fluid itself. This means they can conduct heat more quickly, creating better pathways for heat to move through the liquid. In regular fluids, heat moves from one molecule to another by the process called conduction. Molecules transfer energy when they bump into each other, but this process is slow because molecules are spaced apart and move randomly. When nanoparticles are added, they change the game in several ways. First, the high thermal conductivity of nanoparticles like copper, silver, or carbon nanotubes helps create direct routes for heat to flow. These particles act like tiny bridges that make it easier for heat to pass through the fluid. Second, nanoparticles are constantly moving around due to collisions with fluid molecules, a phenomenon called Brownian motion. This movement stirs the fluid on a microscopic level, creating tiny currents called microconvection, which help spread heat faster. Third, around each nanoparticle, a very thin layer of fluid forms that has a more ordered structure than the surrounding liquid. This nanolayer has higher thermal conductivity and acts like a bridge, improving heat transfer between the particle and the fluid. Fourth, sometimes nanoparticles cluster together, forming chains or networks that create continuous high conductivity paths. These clusters reduce resistance to heat flow, making the whole process more efficient. The shape and size of nanoparticles also matter. Spherical particles are common, but elongated shapes like carbon nanotubes can conduct heat even better because they provide longer pathways. Smaller particles have more surface area, which means more interaction with the fluid and better heat transfer. The type of base fluid makes a difference too. Nanoparticles have a bigger impact in fluids with low thermal conductivity, like oils or water. In fluids that already conduct heat well, the improvement is less noticeable. In real-world applications, nanofluids are used to improve cooling systems in electronics, engines, and solar collectors. They help transfer heat faster and more evenly, which can boost energy efficiency and system performance. So, by combining the high conductivity of nanoparticles with their dynamic movement and the formation of nanolayers, nanofluids make heat transfer in fluids much more effective than in plain liquids. This is a perfect example of how tiny particles can make a big difference in how we manage energy and heat.